Good morning, everyone, and welcome to the last day of DevOps 2023. I think it's 2023. I've got no idea what year it is. It's 5 years since I was last here. I don't know what happened to the last 5 years. It's really great to be back, and I would love to say that I've seen so many familiar faces in the audience, but I can't see anyone. Are you there? Okay, 3 of you are there. Great, excellent. Right, so if you've been following me on Twitter, you'll see that the number of slides in this deck has been going up and down a lot over the last week or so. We have settled on 85 slides for a 40-minute talk, plus 4 live demos. It's probably fine. I might just have to stop halfway through and give it another time, but let's see how it goes. Hello, I'm Trisha. I'm a lead developer advocate at Gradle. People may or may not know that Gradle have 2 products. We have the build tool. Who's using the build tool? Great. And a product that we recently renamed to Develocity, which used to be called Gradle Enterprise, but we're calling it Develocity because it's not just for Gradle, it's for Maven and Maven, Bazel, Gradle, and SBT. Anyway, so that's what that is. That's why there's a name on there that most people don't recognize. I can't remember what I was going to say now. And I've got 84 slides to get through. Let's start. So last year, one of the things I was doing was writing books and finishing books, actually. And the theme that kind of came through in the books that I've been doing around Java and being effective with Java and being good at your IDE and so forth, the theme there is around productivity. It's around how to help developers be productive. Because that's something I feel very passionate about, because in the early years of my career, I felt like I was not very productive as a developer. I felt like there was a lot of stuff which just kind of gets in the way of you doing a good job as a developer. So that's kind of like been my passion for the last probably 10 years or so, really. So that's kind of why I joined Gradle, because Gradle's talking about developer productivity engineering, which is a software practice of trying to get developers to be not only more productive, but happier, which is kind of what I'm interested in, because I don't want developers to be sitting there like hacking out loads of lines of code. It's not a sweatshop. It's supposed to be something that we enjoy. And so this is something I really want to talk about, like how can we improve our productivity so that we can be happier? Now, let's talk about how tests make you more productive and happier, right? People don't agree with this statement. Okay, so this is a good start for the talk. The reality is that sometimes it's our tests which are not necessarily helping our speedy pipeline to production, and we often end up just kind of feeling a bit more like this. There's a lot of Disney stuff in this talk. I really hope Disney doesn't sue me, but I've got kids now, so I spend a lot of time watching telly. Right, so it's okay not to write tests, right? Thank you. If you came here to hear me say it's okay to write tests and then take that back to work, no, that's not what I'm saying. You can leave the room now, it's okay, I won't be offended. That's not what this talk is. This talk is not about not writing tests. I don't want to talk a lot about why tests are a good thing. It's been kind of done to death about why we should be doing tests. I don't really want to make people feel guilty about why tests should be done and you don't really do them. What I do want to talk about is like how we can be more effective with them. Ken Beck said, testing is Xanax for programmers. It's an anxiety-reducing technique. And this, I feel quite strongly like this. I feel like if I have automated tests which prove that my code does what I think it does, then I can feel a bit more relaxed about the quality of my code. And also I feel safer about doing things like refactoring. So that's why tests are a good thing. So I don't want to spend... So I spent about 2 days last week researching stuff about why testing is a good thing and watching a load of videos, and I've condensed it down to one quote on a slide. So, next slide. I like to do a bunch of caveats before I give my talk so that people can kind of set their expectations appropriately. There will be a certain amount of product placement in this talk because I'm a developer advocate and that's kind of what we do. What I'm trying to do is like where I'm talking specifically about Develocity as a product, it will be watermarked on the slide. So feel free to snooze and ignore those if you want to, or call our salespeople, they'd be very happy to hear from you. The other caveat is there's not a lot of really new stuff in this talk. There's a lot of things, a lot of people understand why testing is good, and the techniques I'm going to show you are things you already know. So it's not so much about like brand new, shiny, inspiring stuff. It's about putting it all together and thinking once again, what can we do to make ourselves more effective, more productive, and faster when we come to the test writing process? So the the question really is, what slows you down when you're doing your testing? So I asked this question on a bunch of different social media. This one has the prettiest colors, which is why I'm showing this one. Writing tests comes up quite highly as something which slows you down. Running tests locally, not so much. Running tests in CI, a little bit. Debugging and fixing tests, well, you know. And unreliable test results and flaky tests is something which is kind of like the thing that people say slows them down the most. So I've kind of smooshed these into 3 areas that we're going to look at in this talk. I've smooshed them into writing tests, debugging tests, which includes the unreliable results, and running tests. I really expected quite a lot of people to say that running tests are something that takes a long time, and I'm kind of surprised that people didn't say that, and I'm a bit worried that that's because people aren't actually running their tests, but we'll see. So, writing tests take time. Now, I'm just going to have another caveat. This is why there's lots of slides in this deck. Liz Keogh, when we were mutually at a conference in Australia, of all places, and we were talking about TDD and testing and stuff, and she said to me, "You're actually a tester." And I was like, "No, I'm not. I'm a developer. It's not the same thing." And she's like, No. Like, the way that you think about writing code, the way that you want to do tests, and the way that you write your tests, you have the mindset of a tester. So the reason I want to point this out is because when I'm talking about how to speed up in terms of writing the tests, my caveat is I don't really have a problem with this because I quite enjoy writing the tests and I quite enjoy having the tests there. So I don't really have quite the mindset to address people who are like, "Oh, I don't want to write tests." Because I'm like, why? Why don't you want to write tests? Maybe you can tell me afterwards. I really want to hear the answer to that. So the first answer in terms of how to speed up writing tests is obviously use your IDE. Because, you know, I used to work for JetBrains and I still do loads of stuff in IntelliJ IDEA. So let's have a tiny live demo. What could possibly go wrong? Let's see if we can screen mirror. Thank goodness, that's great. So let's put some glasses on so I can see. I'm old now, I need to wear my glasses all the time. So if you have a class that you want to test, like this one, then obviously you can do a whole bunch of, you can see this, right? You can read it-ish. Well, that's fine, too late. So if you use, your keyboard shortcuts are going to come up on the bottom, like they usually do. You can create a new test from your existing production code. IntelliJ IDEA gives it a whole bunch of defaults, which are kind of sensible. It puts it into the right place, add it to Git, and you can use IntelliJ to generate your new test method. And you say something like, should extract name from input. And then you're going to use all your code completion. Oh, I need to turn off Copilot because I don't want to use Copilot. No, thank you, Copilot. No. Disable. Great. I will come back to Copilot. No, assertions. Assertions. Supposed to be fast. Ah. So apparently, and I'm going to start with as. Yes, I am. Assert equals. Oh, for goodness sake, assert equals, and I'm not going to have an as. I want to say the username has to be Trisha _G, and then I'm going to have what I need a user service, and the tweet is. And we're going to use IntelliJ to fold that away. Ooh, I folded everything away. Marvelous. Don't need to fold everything away. Yes, I'm just going to cut and paste, not use any of the fancy shortcuts. Okay, and then I'm going to put the example input in, and hopefully, and then I'm going to get IntelliJ to fix my errors for me. So I need to make this package private. Let's not talk about whether we test private methods or not. That's not the point of this talk. And then you should be able to run it, and it should pass. Great. Okay, so I mean, it's not rocket science because I've got 4 live demos and I don't want to write really like long tests and show loads of stuff. The basics are using code completion, code generation, using your IDE properly will allow you to write code a little bit faster. You should already know this because you're all developers. Most of you use IntelliJ IDEA already, but it is worth spending a little bit of time rehoning your skills in this area in case there's something which has come into recent editions of the IDE, or in case there's things you didn't know that you could already do. So using your IDE will help speed you up, and obviously running and debugging and so forth. Right, so first live demo out of the way. How are we doing for time? 41 minutes, that's great. I have no idea. This is the first time I've run through this, so what could go wrong? I need to go back to my PowerPoint. Great. So use your IDE. I don't want to go into lots and lots of detail, but what I do want to say is please buy my course. It would be great. And in my course, I tell you how to effectively work with code in the IDE. So go ahead and buy that. That'd be great. I might even give out a discount code if anyone's interested. So let's use AI, because AI is the future, and I promised I was going to put some AI in this talk, so here we go. So let's go back. Oh, why am I even doing this? This is it's Command 1, right? Command F1? Command function F1. Yes, perfect. See, keyboard shortcuts for the win. So let's use AI. Let's turn Copilot back on. I'm going to use a combination of Copilot and AI Assistant from JetBrains. So let's find, I actually have a test here. I'm going to delete this test. I'm going to write a new one using AI. So let's do, but if you saw Anton's thing in the keynote, you'll see that he already showed some of this stuff. Not the AI actions are, so start a new chat. Can you see that? New chat using the selected code. I don't want any of this. So I'm going to say, please write me new unit test for this class. Be nice to the machines, because when they take over, they're going to remember who you are. I always say please and thank you, just in case. And every time I do this with AI Assistant, I haven't practiced this demo very much on purpose, because AI Assistant gives me a completely different answer every time. So there's no point kind of rehearsing it, because you just have to wing it and find out, like, what did you do this time? What do we want you to do this time? So it's obviously supposed to be speeding things up, and it's writing it slower than I could write it. It gives me a whole bunch of methods. Do we want to do anything to change that? It's completely different to the last time it gave me an answer. And you can do things like, let me copy it, but you can do things like, you could say, can you please put all these tests into a single test method? And then the AI assistant will say, don't do that, because that's not a good thing to do. You should have it in separate test methods. And so, oh, that's quite nice. Do it anyway. And it might go ahead and do that. And then, if you decide, oh, no, I don't want to do that. So you can actually do sort of refactoring inside the chat. You can sort of say, can you do this? And what about this? And what if you did this? So, for example, one of the examples it gave me last time is it put loads of stuff in setup. And I'm like, can you not put stuff in setup? Can you put it in the individual methods? So, yeah, you can just kind of ask it to do something. Of course, it might be faster just to write the test, but maybe that's just me. So let's put that stuff in here. Oh, actually give it the package this time. Okay. Does it compile? Yes. And then let's see, what have we got? So you can't practice this, because it just does different stuff every time. Expected mood, actual mood for the key. Okay. What I really wanted it to do is, can we just condense those in? I want to put the key in as well, because what I want to do is I want to get Copilot to make some more suggestions. So in Copilot, I can say assert equals, and it will suggest things like, it will suggest the other values. So assert equals, what else have we got? But you can't rush it. It'll come when it comes. And so all these keys, these are inside the get mood method. It has all these different things. So Copilot will go ahead and go, right, you probably want to write the test for all of these things. And then hopefully if we run them, it might pass. Now, I'm a TDD person, so I prefer to write my tests first. But the reality of the situation is that sometimes you have code that needs to be tested that does not have tests. So I've kind of been playing a little bit with the AI stuff to see if there's a way to quickly generate some not entirely stupid tests, just to at least give you something to hang stuff off, and then start trying to improve them and make them like less stupid, really. Don't call the machine stupid because they might not like it. Right, so AI will make you super productive. And so I asked on Twitter, are people doing this? Are people using ChatGPT or AI Assistant or Copilot or whatever to write tests? And a lot of people are starting to play with it, and it ranges from I absolutely hate it to it's absolutely brilliant. But somewhere in the middle is something like, well, it's kind of helpful, and it's particularly helpful if the code already exists and you want to kind of come up with these kind of exhaustive edge case stuff. And yes, but it did say a lot of the conclusions were you do need to be a little bit careful because AI does do some really stupid stuff sometimes. Yes, I really enjoyed the Barbie movie, so there will be Barbie references. So AI does lie to you. I was asking ChatGPT, I actually did use quite a lot of AI for this talk, which was kind of accidental, but I was asking ChatGPT, can you give me some quotes from preferably some women, for my talk? And so it goes, here's loads of quotes from these people. And I was like, okay, well, when did Agatha Christie say that? And ChatGPT was like, no, she didn't say that, actually. Okay, so double check the answers because sometimes the homework is incorrect. Right, so AI can kind of help you write tests. A technique that I found really helpful is to pair on writing tests. And actually, I found this from Lisa Crispin and Janet Gregory said the same thing. We recommend that the developers who are good at writing efficient, maintainable code work together with the testers who are good at specifying test cases to automate tests. Now, I know the reality is that in some organizations, you don't necessarily have dedicated testers, and there's different flavors of testers and different types of testers, some testers are happy to work with automation, some aren't, and so on and so forth. But the main point here is that you have to have a different mindset when you're trying to create good tests than when you're creating good production code. So I'm reading organizational physics at the moment, which I absolutely love, and it's been talking about the different sort of personality forces, if you like. You don't necessarily stick in one of these boxes. You might move around and be a different type of person as you're doing different types of roles. But I think, generally speaking, when we're writing production code, we're sort of in the producer innovator area where we're kind of being creative and thinking and trying to get stuff out there, which is sometimes what stops us writing tests, because we're like, well, the tests are kind of getting in the way of me producing and getting stuff out there. But in order to write the good tests, you need to be more in the stabilizer side. So you need to be more thinking in terms of organization, quality control, making sure that things aren't going to fall over. You need to think in a slightly different way. So either when you're writing your tests, either you need to try and shift your mindset into this kind of stabilizer mode, or maybe you want to pair with someone who is more naturally in that kind of area, so that we can be thinking in a slightly different way when we're writing our unit tests, or acceptance tests, or end-to-end tests. I really love this quote of, creativity is a wild mind and a disciplined eye. And I think that's kind of where we need to be when we're writing good quality production code. We need this kind of wild mind for thinking of ideas and innovating, and how do we get the user what they want, and how can we plug these things together, and how can we do this? But then you need the disciplined eye to look at it and say, is this really what we wanted to do? Is the code doing what I think it's doing? Is it going to fall over if I do something weird with it? So you need both of these things to be truly creative in terms of creating something that is useful. The last thing I want to say about writing tests, you need to invest time in writing the tests so that you can save time in troubleshooting the tests, because otherwise you need to write good tests so that you can kind of figure out what the test is supposed to be for, how they work, and why they might not work. So let's talk about troubleshooting. Troubleshooting tests takes time. I actually struggled to come up with stuff to put into this section because troubleshooting tests takes time and it's really difficult. And if we had the answers for how to do this, then we wouldn't be struggling with writing tests and troubleshooting them. The first problem I wanted to look at is this: what is this test anyway? I'm thinking about the case when your test fails in probably CI rather than locally. It fails in CI and you have some sort of error, and the error is something like, I am a test and I failed. And you're like, thanks. And this screenshot embodies the two things I hate the most about suboptimal tests. One is a test method which doesn't really tell you anything. You're like, test increment. You're like, okay, so am I testing that it increments? Am I testing that it increments correctly? What am I testing with the increment? Do I want it to work or I don't want it to work? And then using assert true, which I absolutely hate, because whenever assert true or assert false fails, it just goes, I thought it would be true, but it's false. And you're like, what? What did you think was going to be true? And why is it false? This doesn't give you any help whatsoever. So again, although I'm talking about like help troubleshooting tests, it comes a little bit back down to writing the tests helpfully in the first place. For example, having a useful test method name. And in JUnit 5, you don't just have to have a method name, you can put a descriptive piece of text so that when it fails, you can see it failed to correctly identify happy messages. You're like, okay, and why did it fail? Because I expected one of these and I got one of those. You're like, oh, okay, now I kind of have a clue for where I'm going to start looking. And obviously you've got line numbers for where it failed and stuff, but I have a clue for where I'm going to start looking at this. The tests need to be able to tell you, or at least give you an idea of whether the test failed because the test is no longer valid, or if the test failed because the production code is incorrect. So you need to kind of structure your code your test code in order to do that. So some ways to kind of help you with that is things like, I really like using should as my method name, or at the start of my tests, because it really helps me think it should do this under these circumstances. You're like, okay, it should, but it's not right now. So I like to use the word should. I'm going backwards, so I need to go forwards. I also really like to use, I forgot to use live templates in my demo. Curses. Live templates is a really good thing too. Oh, let's do it now. Why not? What could go wrong? More live demos. Let's show live templates. So live templates for creating methods. So I've got a live template here, which fills out, and I can start typing that. So I'll say should show me something useful. And in this case, the live template kind of uses the description and creates the method name. And I want it to automatically fail to begin with because I haven't done anything. The other thing I want to do with this live template, which I haven't done yet, is I want it to do given when. Oh, look, Copilot's really helpful. Oh, that's nice. Awesome. Okay, and then so if I have that coming up with my live template, then once again, I'm thinking in terms of, okay, the given when and then. The when is the most important thing. That's the thing I'm trying to test. Like, this is the thing I really care about. Okay, now, given that that's the thing I want to test, is there anything I need to set up first? And what do I need to do to assert that it did what it was supposed to do? So I really like given when and then. It's one of the reasons I keep coming back to Spock as a testing framework, because it does it by default and it's really nice. Right, so you need to do given when and then. That's a good idea. You need to have useful method names. And in order to kind of prevent test brittleness, you need to be thinking about testing the behavior, not the implementation. And particularly for unit tests, this is where we often fall into the trap of, particularly when you write your test second, you know what the implementation looks like. So your test says, are you going to follow the steps that you follow in the code? But then when anything changes, it's very brittle and it falls over and you're like, oh, I don't know if the test is bad or the production code is bad. So your test kind of needs to lead you in the direction of, is it the test or is it the production code? Okay, I told you there'd be more Barbie. So the other thing is you need more information in order to be able to troubleshoot what's going on with your test. So one of the things I wanted to show you, you can use the remote debugger in IntelliJ IDEA. I'm not going to demo that because that's just long, but I've got a link for a tutorial for that later on. What I can show you is, let's have a look at, let's say that you have let's say that you get a stack trace somewhere on some machine somewhere, and you're like, okay, this is kind of great, but what I really want to do, so let's say this comes up in CI. So you copy your stack trace, and you can actually just paste it into your IntelliJ IDEA. Use analyze stack trace, and because I've got it on the clipboard, it'll just put it in here. So then when you say OK, It'll open up inside an IntelliJ IDEA window, and then you can do things like click to get to the exact place. So you can actually sort of navigate through the stack trace. Obviously, it kind of relies on you having the version of code in IntelliJ IDEA, which is the version which is running, which has thrown the exception. But it's a really good way of trying to actually like tie together some errors you see somewhere else and bring it locally onto your machine. The other thing with AI Assistant is it says explain with AI, and and it usually says this shows you that the address is already in use. Well, I kind of knew that anyway. But it also tries to give some suggestions. Maybe you might want to make sure that you retry on a different port, or here's some code that you could use. So that's actually quite interesting. What else? Oh yeah, and the other thing you need to do. I need to play my thing. The other thing you need, if you're going to effectively troubleshoot some of your tests, is figure out like what were the conditions under which this test was running. So, for example, this is a Gradle build scan. You can get the build scan for free for Gradle and Maven, and it will tell you things like the infrastructure it ran on. This is helpful for, let's say, a developer on your team runs a test and it fails, and they're remote to you, you can't see them, and you want to get a bit more information about like what was running when it failed. Then if they run it with a build scan, you can see their operating system and the JVM they were using and all these other any switches that were used. And so this way you get a better idea of, okay, what were the circumstances under which this test failed. Also useful for CI, so that you can do like comparisons of, oh look, it's always the Windows ones that fail, or whatever it is, or this is a slightly different version of Java, so maybe the behavior is a bit different. The thing that's really important for troubleshooting tests is it's helpful if you've got fast feedback and easy reproduction, right? Because if the test takes 45 minutes to run, and then you have a theory about why it might be failing, and you make one change, and then you run it, and it takes 45 minutes to run, you're just like, why? Why is my life like this? Ideally, you want to be able to run it locally, which is why I talk about easy reproducibility. So if it fails somewhere else, you want to be able to rerun it and see the same problem locally, which is another reason why you kind of want to know the infrastructure and conditions under which the test ran in the first place, because otherwise you can't reproduce those conditions locally. A very wise man said to me while I was talking about this man is my husband, by the way, he said, 99% of the time, the best way to troubleshoot a test is to rewrite it so it's smaller and faster. So Israel does a whole bunch of stuff with Android and with web tests, and he does a lot of end-to-end tests. And he often does the thing that lots of developers do, which is like, I'm going to write an end-to-end test using the Android emulator and a whole bunch of other stuff. And then because it's quite expensive to spin this up, then I'm going to test a whole bunch of things just to get to the point where I really want to be. And then when it falls over somewhere in this 5-minute test, he's like, I don't know why I did this again. I need to pull this out into a unit test, and I need to make it smaller. I need it to be run quickly so I can figure out, was it this bit or this bit or this bit? So you really want to, going backwards again. So you really want to be able to run it as quickly as possible. You want fast feedback so that you can keep making hypotheses about why this failed, make changes, run it again and see if it passed or not. Now let's talk about my absolute favorite thing. Flaky tests. I absolutely hate flaky tests. When you have tests which fail for like no real known reason, even if you've got one or two of these things in your code base, what happens is you basically stop trusting the code base at all, because you stop trusting the tests at all, because you're like, well, we have flaky tests, so sometimes, it just fails. Just going to ignore it, really. And so flaky tests they're frustrating for team morale. They make troubleshooting impossible because sometimes it passes and sometimes it fails, and you just lose faith in your entire test space. So the thing that you really want to do with flaky tests is first, you want to identify the flaky tests. You want to figure out which ones are really failing and which ones are occasionally flaky. And so in Develocity, what we do is we have automatic retries. So if a test fails, you can turn that on. So if you turn on your automatic retries and a test fails, then you retry it, and if any time in the next 3 or 5 reruns of the test, it passes, it gets flagged as a flaky test. Because obviously if you're rerunning the same test under the same conditions in the same environment and it passes and it fails, that is a flaky test. You don't have to do it that way. I used to work in another environment when I used to work with Dave Farley, actually. we made a tool called Trish, named after me, because what I used to do is I would get in the morning, I would look at the test results on CI, and I would look and I would see, okay, some of these tests have been failing for the last like 5 builds. Some of these tests pass, fail, pass, fail. And I'd send out an email and say, like, this is the state of CI right now. This is the state of the tests. These people probably broke the build here, and these tests are flaky. So someone decided that that was probably not a great use of my time, and that they automated this for me, which is fantastic. But the way that this analyzes flaky tests is from build to build. Does it seem like this is broken, or does it seem like maybe it might be flaky? Okay, so now that you've identified the flaky tests, that lets you ignore the flaky ones and focus on the failing ones, right? Do not ignore your flaky tests. Do not just go, oh, you know, I've got flaky tests, that's kind of fine. Now I know which ones they are, I'm going to ignore them. No, fix your flaky tests. Not necessarily immediately, because I know that you're working on a bug or a feature, or you've got something else to do. So you can do things like you can schedule flaky test days, you can do it as part of your 20% time, or you can do it when you're kind of in that area, have a look at the flaky test. Now, I know flaky tests are really hard to fix, because by their very definition, you don't know why they broke. You don't know what's causing them. So my old boss, Dave Farley, has a really good video about the 5 causes of test intermittency, and talks about all these different things that could contribute. For example, infrastructure or race conditions, or all these different things. So it's a really good breakdown of the types of causes of your flaky tests. And I love this so much that I wrote 3 blog posts for the Develocity blog about flaky tests and how to fix them. So there'll be a link for that at the end of the talk. But I do have some guides on the kinds of buckets that might cause buckets of problems that might cause flaky tests. Okay, part 3: running your tests takes time. So surprisingly few people were worried about running the tests. Who here thinks that running their tests takes too long? Perfect, great. You're the perfect audience, awesome. Because otherwise I just won't do the last part of this talk. Running tests takes a long time. So I asked how people speed up running their tests, and it turns out that they speed it up by not running the tests. And I was like, okay, fair enough. Maybe 70% of people don't use skip tests all the time. Maybe they just use it when they want to do a build. But it was a bit worrying that 70% of people just go, skip tests. Won't run them. Makes it much faster. However, they do have a good point, which is that the fastest test is a test that doesn't run, right? So how can we identify which tests we don't need to run? Because we might not need to run all the tests all of the time. The first thing that you can use is a build cache for this. Let's see if I can demo a build cache. A build cache, so everyone knows what caching is, right? Given the same input, you should be able to have the same output. So if in a Gradle task or a Maven goal, you have the same set of class files that you had last time you built it, you don't need to rebuild that or rerun those tests or do anything with it. You just need to get the results from the cache. So that's what a build cache does. So if I show you an example of this, I told you I had loads of live demos. In this project, this is a multi-module Maven project, which takes about 4 minutes to run. It's using test containers, and it's got a bunch of end-to-end tests against the MongoDB database, which is why it takes about 4 minutes to run. There's not loads of modules, but there's enough modules. Now, if I enable the build cache, which I'm going to use Develocity, which used to be called Gradle Enterprise, to do. The reason I have to mention it's called Gradle Enterprise is because it's still called Gradle Enterprise. Unshelve these changes. Let's see that they're there. Now, if I rerun this, hopefully, this is the most risky live demo. I ran this at DevBCN, and it just errored. I was like, never mind the build cache, don't use one of those. Right, so we should see that it will say, there we go, loading. It says loading from a build cache. Where is it? Loading from a, I saw it. Stop scrolling past. Loaded from the build cache, saving 1 second. Okay, 1 second is important. And there you go. And so it runs the whole thing in 18 seconds instead of 4 minutes, which seems pretty good to me. This is because I reran it without making any changes. But if you've got a multi-module project, you can imagine that the build cache is going to fetch stuff from the cache only when something changes in the area. Let me show you what I mean. So for multi-module projects, normally, particularly for Maven, but not just Maven, and you can get around it in Maven. If you make a change, you have to recompile everything, okay, all of your modules, which just takes ages, unless you selectively say, I only want to rebuild this one. With a build cache, the build cache can intelligently tell you which ones you really need to rerun. So if I change the export API module, for example, then it will, if I change it doesn't really matter, public method or implementation, it will recompile it, test it, run check style or whatever, and recompile the tests. So you don't need to rerun everything. Okay, that's great. And then maybe you change the implementation of one of the mid-level modules, not the public API, just the implementation. And then all you need to do is rerun the tests for the modules that are dependent on that module. You don't even need to recompile because it was an implementation detail in the service. And the only sort of worst case is when you change something in something like core, then you have to rerun all the tests on all the modules. But you get this idea that for every build that you run, you don't necessarily have to run everything all the time. So you get quite a lot of savings from using something like a build cache. The build cache is really interesting as well, because if you have a remote build cache, then when CI does the build and runs the tests, you can get those results on your local machine, and you don't need to rerun it. So let's say you do a get first thing in the morning on a Monday, you don't need to rebuild your entire project on your laptop because CI did that for you. So when you say build using Maven or Gradle, it will actually just pull the results from the remote build cache and save you so much time on all of that stuff. Another thing you can do is obviously run the tests in parallel. Shall we run the video? No, let's do a demo. What could possibly go wrong? So I'm going to use Gradle for this. Right. I am going to compile the Groovy, the language, because it's a lovely Gradle project and it works really well for parallel. So let's just run that. And what we should see, I'm not going to minimize my PowerPoint in case I don't get it back again. Right, so you see it going parallel there. You've got multiple parallel threads. If we open up the activity monitor and we open up the CPU usage, you can see these are all my cores and they're completely maxed out. That's the point about going parallel, right? So that when you're going parallel with as many threads as you have cores, you should be using all the cores. And then of course what you're going to do is slow down when you're downloading all the dependencies. See, I tested this yesterday, which is why I've got a video for this. But you did see the CPU cores get maxed out, so you get the idea. You can run stuff in parallel, you make the most out of your multiple CPU cores, and so you run stuff faster, which is nice. We want to run stuff faster. Okay. I do not want that. So run tests in parallel local. Don't need to use the video because my demo worked. Yeah. Obviously, you can run tests in parallel in CI. I'm pretty certain everyone's doing this anyway. I took this from Team City. You have multiple agents running your tests in various things. Whether you slice and dice it by operating system or by functional area or by both, you will be running your tests in parallel in CI, I assume, especially if it's big enough. But there's another technique that you can use called test distribution. And test distribution works in parallel. It gives you parallelism for your local build and for CI builds if you want to. The downside of going parallel with something like the thing I just showed you using parallel threads with Gradle is that the optimum thing is to use all of the CPUs on your laptop. So you can only go to sort of 10 agents in parallel. With test distribution, you run your agents on different machines all over the place, so you can go much more parallel than that. Is that a thing? Be very parallel. And we actually did this. We home grew our own at one of the places I worked. And so you run these agents on these various machines, and it could be even on everyone's laptops as well as in the cloud or whatever. You have some form of test distributor which works. You can write this sort of thing for a JUnit 5 based test quite straightforwardly. I haven't done it, so who knows. By the way, Develocity does do this, so you can actually just buy something to do it for you if you want to. And then when you run your tests, whether you run them locally or on CI, the test distributor will look at your list of tests and go, right, I'm just going to put it on this agent, this agent, this agent, this agent. And so you can go very parallel. And what you'll find is that generally speaking, when you double the number of agents, you halve the amount of time the build takes, obviously, because unless you've got one really long running test, and then that's your bottleneck really. And Netflix used this to reduce their test cycle time from 62 minutes down to 5 minutes, which is quite nice. what I really like about this is that it works for your local machine. So you don't just have to keep pushing stuff into CI in order to get in order to be able to use these parallel agents. You can run all the test suite on your local machine. This comes back down to how can I easily check and debug problems? Well, the best thing to do is run it locally so that you can see what's happening. And if you can run things in parallel, that kind of helps. All right, more AI stuff. Another technique you can use to kind of speed up running your tests is called predictive test selection. There was a paper by Meta about predictive test selection. And what they were trying to do is figure out which tests they didn't need to run. So the hypothesis is that for a small code change, particularly for something like a monorepo, for a small code change, you shouldn't have to rerun all of your tests. How can you figure out which tests you need to run? And they figured with a machine learning algorithm that the selection procedure selects fewer than a third of the tests that would have been selected. So it only runs about 30% of the tests. And it gives 95 to 97% accuracy in terms of, like, if you had a problem, it's 97% likely to find that problem. We found with some of our customer data, we found that, so if this is the full build time, 100%, some time is spent not doing tests, like building or whatever. The red and yellow, I'm colorblind, I don't know. The red and yellow combined is the total testing time. But you, with predictive test selection, with the simulations we ran, said that that top one, the predictive test selection, will save you from running 95% of your tests. So you only need to run the little red bit. And mostly it's around about 60, 70%. It will save you from running 60 to 70% of your tests. So then your total build time comes right down because you don't have to run like half your tests. And what else did I want to say there? So yes, so there are going to be times when you're going to want to run all your tests. So you don't necessarily want this everywhere all the time because obviously before you push to production, you probably want to run all of your tests. But when you're running locally, just to make sure you didn't do something stupid before you commit, probably predictive test selection will give you that kind of certainty that you probably didn't do anything stupid. Okay, so I was talking about this to someone in the London Java community, and they said, like, but I just have so many tests, and that's why it takes so long to run them. And even, like, they could make a start using test distribution and predictive test selection, but what they really wanted to do was just get some idea of how to reduce this huge burden of tests. And so my suggestion was we should probably delete some, I think. And so I asked Twitter, like, do people delete tests? And Angie Jones said, yes, I regularly delete tests that no longer add unique value. And Angie knows what she's talking about when it comes to testing. So it's an important part of the process to be able to also, like, tests don't have to live forever. You can kind of, like, allow them to die and get rid of them. But the difficult problem is, like, how do you identify which tests you need to delete or do something with? How can you find duplication? How can you figure out, like, maybe there's some areas which some tests which just need some love or to be deleted? So Twitter kind of suggested to me, not just Twitter, actually, it was also Mastodon, also suggested to me you can use things like coverage tools, you can use mutation testing, profilers, things like that to identify possible duplicates. And another interesting thing, again, it was Angie Jones who said it. She said that if for a certain type of problem, the same set of tests always fail at the same time, then these tests are clearly testing the same thing. Now, obviously, there's always going to be things which are going to fall at the same time. So, like, if login stops working, then all the tests stop working. But groups of failing tests are an indication of possible duplication, and maybe you might want to do something about that. However, a really interesting point was made, which is that it's not necessarily the number of tests that's important. So you can have, like, 1 million fast-running JUnit tests, and it still takes like just 3 minutes or whatever. I don't know, I just made these numbers up. It's not so much about the number of tests, it's more about how long it takes to run each of the tests. So this is just a classic performance problem. You need to look at the stuff which performs worst first. I don't know if anyone was in Holly's talk, was it yesterday, about performance. It's all about, you have to measure what's actually happening. And when it comes to performance tuning, we kind of want to fix the quick wins, the things that we think we understand what's going wrong. But in actual fact, the best way to win is to look at the longest running ones and go, Does this really need to be such a long-running test? And ideally, what you really want to do, of course, is try and push them down the testing pyramid. So end-to-end tests are helpful, and you do want end-to-end tests, but you don't necessarily need to be testing every single edge case of validation in an end-to-end test. In an end-to-end test, you probably want to check, does the system kind of start? Does some validation get fired on the UI? And then down in the unit tests, you can test all the weird edge cases of whatever regular expression you're using. So you really want to try and push stuff down this pyramid if you can. And I was listening to this podcast, Kelsey Hightower said, once things like databases become a hindrance, optimize the testing loop, mock things out to run things fast. You can run locally and don't have the same infrastructure dependencies. So he was sort of suggesting that, like a lot of developers, we kind of want to run a whole bunch of stuff end to end, especially when we get started, because this allows us to reason about the system and gives us sanity checks that the system's kind of working. But as you go on, you might want to sort of break those down a little bit and start having maybe some mocking and stubbing, but not necessarily using a mocking framework, and that's another discussion for another thing. But you don't necessarily want to do everything in all your end-to-end tests. You want to kind of mock out some stuff and have stuff fast running. And really, you want to look out for expensive setup and teardown. So, yes, I've just got loads of minions looking at me now. It's quite scary. So expensive setup and teardown is a really big smell of that can cause production problems, performance problems. Because, of course, setup and teardown will run for every single test method. And not all of your test methods necessarily need a database connection with new data in that does one of these things, and then you've got one of these, and then you set this up, and you're like, all I'm testing is that 1 equals 2. Well, obviously it doesn't. But you want to look at these things. These are kind of smells to look for. I was looking at, actually, it's that project I just showed you earlier on. The build time of 4 minutes, it used to have a build time of 90 seconds. And what it used to do is it would rely on you creating an instance of MongoDB under the covers somewhere and have it running, and then it would run all its tests against MongoDB, and then it would shut down. And what the new version of what the new code does is it uses test containers, which is a good thing. We should use test containers, but it kind of creates them for every single test method, and it went from 90 seconds to 4 minutes. So you have to think quite carefully about the costs that you're incurring when you're doing these kinds of things, and I'll talk about that in a minute as well. So this is kind of like part 4. Oh, 5 minutes left. This is great. Part 4, respect your test code. This shouldn't be rocket science, but your test code is part of the production process of producing production code. So you should respect your test code the same way that you respect your production code, which means doing the same kinds of things we do with production code, and having separation of concerns and encapsulation, and being able to refactor it. Oh, I've got refactor in a different thing. Design for performance, modularization. With some of the things that we were looking at with test distribution and things like that, that doesn't work if you've got like one huge test method that just runs everything in serial. So well-designed tests will perform better. But there is some tension between these things. Like I mentioned the test containers thing. If you have very good separation and you have and in order to do that, you're setting stuff up over here and tearing it down over here, you might end up having poorer performance. So you have to understand the trade-offs between these different things, the same way you need to understand the trade-offs when you're writing production code. You also should, in my opinion, regularly revisit and refactor your tests the same way you would with production code. It's important to be able to refactor these tests. And refactoring is about tidying up the code. And Kent Beck's writing a new book called Tidy First, which I can't wait to read. And he says, tidying is software design addressing you, your relationship to your code, and ultimately your relationship with yourself. Tidying is geek self-care. And I really like this idea. I love the idea that taking the time to tidy up our tests and tidy up our code is a form of self-care. And I feel like this kind of comes into this developer productivity, developer happiness thing, about not just like running, but taking the time to think about what is going to actually make us more effective. In summary, In order to make your tests run faster, in order that your tests don't slow you down, whether it's writing tests or debugging them or running them, you want to automate as much as possible. We know by now that manual processes are the things that slow us down. And I don't just mean automate the tests, I mean automate all the things that around the tests, like when you rerun them, and automate finding flaky tests, and automate distributing them, and so on and so forth. So automate as much as possible. And there are solutions out there designed for exactly this problem. For example, maybe Develocity, if you'd quite like to take a look, but not limited to Develocity. The thing that is difficult to speed up, really, is the process of writing the tests. But writing the tests is going to take time because you need to be doing the thinking. And it's the thinking that takes the time, not the typing. We know this, typing doesn't take time. And I can show you as many IDE tricks as you like, but that's not the thing which is slowing you down. What's slowing you down is, what is the behavior supposed to be? How do I prove to myself that I have got the code to do what it's supposed to do? I like the fact that tests are a kind of challenge to yourself to prove that you've thought of everything. And I like that because at the end of it, I've got loads of little green ticks which says yes, 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 yes. But we have to think about them, and that's what's going to slow you down. Ada Lovelace said, your best and wisest refuge from all your troubles is in your science. This is fundamentally an engineering problem. Apart from the thinking is the thinking thing. But all of the other stuff in terms of like speeding up how to run tests and optimizing things that shouldn't be manual, this is an engineering problem and we should be looking at it from an engineering lens. Are there things that you're doing or that your team is doing that perhaps are getting in the way of you being effective with your tests? Are there things that could be automated and simplified and smoothed out? We need to measure that. We need observability and measurement to know the answer to that question. Thank you very much. This QR code will take you to a page on my blog, and it's got like a whole bunch of links to everything I mentioned, all the videos I watched, and everything that kind of went into putting this talk together. So if you're interested, do go to this webpage because there's loads more information there. And there's no time for questions, so thank you and goodbye.